Great. Hi, everybody. Hope you had a wonderful night's sleep and are ready to start the day with some APIs and promises. Yeah. So we're going to continue with the slides from yesterday, and we're going to start with making requests to APIs in JavaScript. We briefly talked about this yesterday, but I just want to go over it because I think the end of lecture yesterday probably went kind of quickly because I was trying to get through as much as possible. So yeah, so basically once we hop into the code in workshop 3, we're going to be writing get requests, get and post requests, not from like URLs, but rather from using these get and post functions that we have written for you in JavaScript. And what that will look like is you feed in an endpoint and then a set of parameters. And for get requests, your parameters will be put into the URL for you so that it will request the endpoint using those query parameters which are put in the URL. And then for post requests, it will also do the intended thing, which is put your parameters into the body of the post request. So it'll post to that endpoint using the parameters which are in the body, basically. Yeah. And we'll review this a little more, but basically get and post requests have these two different formattings, which is why when you call these functions, don't actually have to worry about these two different formattings, but you should know that under the hood, some slightly different things are happening, basically. Yeah. Okay. So once you get into the code and then you try typing out something like this, where you get from an endpoint, and maybe generally you can hover over any variable and figure out what type it is. You'll see that this user variable that you get back from the get request is a promise anything, and you might wonder what is a promise? And let's say you try to console log user, you would just get this object promise thing, which doesn't actually mean anything. Yeah, it turns out these get functions return a promise. And so what actually is a promise? Basically, these API requests might take a while to resolve. And so if the API request had to return the result and the client had to wait for it the entire time, let's say the API request took an entire second to resolve, then the client would just be sitting there for 1 second, not being able to do anything, waiting for this function to complete. So the promises allow the clients to do things while the server is taking its time fulfilling the request. For example, maybe they want to render the rest of the front end and then put a loading icon there, some circly thing that's spinning until, oh, I got the data, now I can just put it in. Yeah, let's say Bob the builder is trying to build a house, and then he's needs more wood. He asks the lumberjack, can I get more wood? And the lumberjack comes back with some wood. He had to go chop down some trees, so it took him a while. But in the meantime, Bob did not have to wait the entire time, just sitting there doing nothing, right? The promise allows the lumberjack to be okay, I'm going to work on it, rather than Bob being okay, I have to wait for the lumberjack while I do nothing, basically. Yeah, and we'll talk more about this on Friday. Yeah. Okay, but for now, let's see some examples of how to use promises in JavaScript. So the first way that you kind of process code with promises is you use something called .then. And so what this does is it takes a promise, or more you use .then on a promise, and it takes a callback function, which takes whatever the result of that promise is and does something with that result. So what this will do is basically get API/stories. It returns a promise, but that promise is going to eventually resolve into some story object, basically. And once that resolves into like those story objects, then you can set stories to story objects. Imagine set stories is like some use state thing that we have. We can now like set our state to like story objects basically. Yeah. Any questions here? Cool. Yeah. Okay. Yeah, and then the second way that we have to deal with promises is using a dot catch. Sometimes the promise is not going to resolve into, it's not going to resolve successfully. Maybe /API/stories is not actually implemented in the API. Then like if you try to like get /API/stories, you're going to get back like eventually an error. First, you're going to get back a promise, and then that promise is going to resolve into like, hey, like I wasn't able to do this because I just simply do not have the resources, or like maybe I just like messed up in the meantime and like I errored out. Whatever reason it is, like the promise can reject, and in that case, you like the dot catch will basically catch what happens in that case. So, and then you're able to feed in a callback function which takes in whatever error it does and does something with it. So here, if the promise rejects, then it'll print out this is so sad, and then the message of the error. Yeah. So you can see generally we use a dot then, and then potentially a dot catch to catch whatever errors might occur. Yeah. Cool. Yeah. I think I'll skip this example. Okay. Oh, I'm not on Zoom. Great point. Wait, am I on Zoom? Okay. Sure. Hi, Zoom people. I'm very sorry. Yeah, so just a quick summary of what we just talked about. So we went over the basics of making API requests in JavaScript, and then we talked about promises, which is essentially what API requests will resolve to, and you need to wrap promises around these, like, we talked about how you need to wrap promises around these like dot then and dot catch keywords so that you can either process what the result of the promise eventually resolves to in the case that the promise does resolve, or you can catch and do something with whatever error the promise happens to give if the promise fails. Yeah. Hopefully the slides are, if you have any questions about it, like feel free to ask in the questions doc. Yeah. Okay. Oh shoot, sorry, I accidentally just like gave the answer. My bad. Okay. Yeah, so let's go over this example. I realize that the code on the slides is like kind of hard to read because the color scheme is like kind of bad, but if you need to pull up the slides on your own computer, feel free to do that. But yeah, what gets printed here? Let's say the promise below is going to reject, where we have like this const promise, and then yeah, this is like really hard to read actually, but let's say we define this const promise and we know that it will reject. Maybe there's a network issue or something like that. Then hold your hands up, like finger like 1, 2, 3, 4, or 5. If you think like you're gonna get the first answer printed out, then you raise up 1. If you think you'll get the second answer printed out, then 2, etc., 3, 4, 5. Which one do you guys think it will be printed out? I'll give you guys a second. Okay, yeah. Do people have like an answer? I see a few fours. Yeah. Okay. Yeah, so we are going to get the fourth one. We're just going to get the error because when the promise resolves, it's going to reject. So we're not going to be able to process any of the .thens, which will only process if the promise succeeds. And therefore, we'll skip straight to the .catch at the end, which console logs an error, basically. Yeah. Cool. Yeah, so let's look at this example now. Let's say the promise below, where we define const promise, is some way of getting a promise where we know that it's going to resolve after a little while. Let's say that the promise resolves after 1 second or something like that. Then when we write this code, which one of these choices are we going to get? I'll give you guys like again like a little bit to think about it. Yeah. So basically, like the code here, promise.then will console log. If we get a value, then we'll console log a, and then from there, if we were able to successfully do that, then we console log b, and in the process, if we caught any error, then we will console log error, basically. Huh? Really? Is it working now? Is it good now? Okay. Yeah. If people have some guesses, hold up 1 for if you think the first one's going to be printed out, 2 for the second one, 3, 4, and 5, so on. I see a few different answers. I think I see like 2 and 5 the most. Let's look at the code. So what exactly is going to happen? We'll run f of promise, and when we run f of promise, we're not going to wait for this promise to resolve necessarily. We're kind of just going to send it off and wait for, and whenever the promise resolves, then like the rest of the body of f is going to run, basically. So after we call f promise, we can immediately move on to the next line, which prints hi there. And then if the promise resolves after like maybe a second or something like that, then we'll get the rest of the output from f. So yeah, we're going to get the second output, which is hi there, and then a, and then b. Cool. Okay, yeah, so that's it for this lecture. I think we were just finishing up slides from yesterday, so we'll just move on to the next lecture now, wherever that is. All right. Cool. Yeah, in the meantime, you guys can take 1 minute to do web.lab.is/feedback if you want. If you didn't already do it yesterday, or if you want to like give more feedback, yeah, while we transition the slides.
All right, can you guys hear me? You guys hear me in the back? Okay, cool. All right, so now we're going to go into servers and Node. So what is a server? Well, a server is just some computer that our client requests data from. So we're going to send a request to the server, and it's going to give us back data. And a server can actually handle many requests from multiple clients. So this allows for scalability. We don't want a server for every client, because then it'd just be like too many computers, and it would just be like a waste of money. And so why do we need a server? Well, first off, it's because we want to request the data from a central point. So we want all our clients to know that at this website or at this URL, we can get the data that we want. We also want a server for centralization. We want some ground truth to represent the data that we have in our server. An example would be like, imagine you're playing Fortnite and like you shoot somebody. You want there to be some kind of true game state that both players can refer to if they want to see or if they want to render something on their screen. And then the final need for a server is security. We don't want our client to be able to access our database and send any kind of query to request maybe data that shouldn't be accessible to them. We want them to go send those requests to the server, and the server deals with the logic necessary to retrieve refined data to the client. But how do requests actually reach our server? Like right now, we've been telling you that we send requests to a server, but like, how do these requests actually reach our server? So I lied a little bit when I said that like a server was like a computer. In reality, a server is a program. It's called a process, and like on your computer, you can run multiple applications, multiple processes. Like you can run Spotify, and then you can run Chrome, and like some other applications at the same time. The same is true for a server computer. On a server computer, we have multiple ports, and a server just binds to a port. So a server will be an application that binds to a certain port, and on that port, that server will be listening for requests from some other computer. So an example for like a port address and a URL would be http example.com and then 5173. And this indicates that we're sending a request to the computer associated with the domain name example.com, and it's going to the port 5173, because that is where our data is going to be served. Another example would be example.com 3000. And we use these port names because whenever you run npm run dev, you're actually like hosting a server on your computer, which is just sending you the React files that your browser will render. And so here's like the general like structure for like an address to a server. And why do we need to specify ports on most websites? Well, in actuality, most websites actually have like a default port. So for example, the youtube.com servers, like if you want to request the website from them, they will be using port 443 to send you the website through the protocol HTTPS. If you're requesting a website from youtube.com using HTTP, you'd probably use like port 80. And then there are other things that use different ports as well. So a Minecraft server would use port 25565. And then if you want to send an email to somebody else, the email is like, if you send an email to your friend, it's going to go to your friend's computer on port 25, because that is where their email application is listening for emails from other people. So you guys are going to be developing websites. You're going to be interested in like how you can use your own machine as a server. And any computer can run server code. But what does it mean to run server code? Well, that just means that, oh my God. Well, that just means that you will run a program that is designed to actively listen for requests and from other computers on a network, and then actually respond to those requests. So your computer has a special domain called localhost, and localhost is just like a word that represents your IP address. So whenever you type it into your browser, you're actually just sending a request to your own computer through a certain port, depending on like what you put after localhost. And so like this would be an example of connecting to a server on port 3000. How do we write a server? So I've told you how like a process can listen for requests on a port and then like actually respond to those requests. But you as developers, you guys want to be worrying about how to create your website. You don't really care about how your computer is handling these requests and then sending back responses. And so this is where frameworks come in. Basically what frameworks do is they have like boilerplate code for like low-level like request handling, and they just like make it really nice so that you can use it easily. And so some examples of this would be Flask, Apache, Express.js, Django, and all of these frameworks. The only like difference between them is that, like you'll use Flask if you're coding in Python for your backend. Use Apache if you're using Java, Express.js using JavaScript. So it's just a way to like abstract out all of that like low-level communication stuff that you don't really care about. What framework will we be using? We're going to be using Express.js, and later Daniel will show you how you'll be able to write API endpoints on your backend, so on your server. But we also need a tool to run JavaScript code. And like you might be asking yourself, like, what do you mean? Like, we already run JavaScript code on like the browser, right? Yeah, that's true, but like, we're not going to be running our server on a browser. The JavaScript that we run for like on the browser is for the client. It's used to like render the HTML, CSS, and JavaScript that some server sends to us that like represents our website. So I'll give you guys like a little refresher. So basically, whenever you send a request to some website like youtube.com, in order to actually render the website, you're going to be asking the server for HTML, CSS, and JavaScript. The server returns it, and your client, the browser, is going to be interpreting the HTML, CSS, and JavaScript so that the website is actually rendered in front of you. But what about the code that actually like handles these requests? Like this JavaScript code is going to be on the server. And so like I have a little meme here. It's like, what if I told you that your computer does not know what JavaScript is? And this is because like if you gave your computer, your machine, like a file of JavaScript, it won't be able to interpret it unless it has some packages that are installed to actually interpret JavaScript. And so essentially, your browser, like even though it's on your computer, it knows how to interpret JavaScript, but your computer, like your terminal, everything else, it doesn't know how to like read JavaScript. And so that's why we have Node.js. And Node basically just runs JavaScript on your machine. And we've actually been using it to download any dependencies we need for our project. And I'll talk about that right now. So before that, any questions? I know that was like a lot. And it's like a little bit confusing, like connecting the front end and back end. So anybody have questions about anything? All right, cool. So Node Package Manager. This is just going to give some context on like how we've been using NPM. So obviously, we've been using it to download packages that our project needs using npm install. And then we've also been using it to run our server in the background, or rather, running our server to service the React files on front end that we need to actually display on the browser using npm run dev. So importing packages. So if you guys look into Capbook, your folder for Capbook, you'll see that we have a package.json file. And this file just has a lot of metadata about our project. So it has a name, description, probably some scripts that you'll be running, like npm run dev. and dependencies. And we'll be looking at the dependency section. So whenever we run npm install, we download dependencies, and those dependencies will be shown in package.json. And the actual packages that we download will be going into Node modules. And whenever we push our project to the GitHub Git repo, we don't want to include our Node modules or whatever modules we download. That's why we always npm install whenever we pull from a Git repo. Because if we pushed all those packages up to the Git repo, it'd be very slow, and we don't want to do that. So let's look at the big picture. What are our files actually doing? So for Capital React, we're going to have a client folder and a server folder. And it might be a little bit confusing, having both of these folders in the same folder on our computer and then running the server and having a front-end server as well. But because our computer has multiple ports, we can run multiple servers. And so our client's going to deal with all of our React code, components, pages, utilities, et cetera. And our server is going to have all our back-end code. And then all these other files are just set up by staff to configure React. Feel free to ask any questions about these files in office hours, or maybe after these lectures, if you want to learn more. And let's see if I have enough time. OK, I'll go through this just to clarify a little bit more about endpoints. So an example for understanding endpoints. So we've been talking about sending requests to endpoints, like youtube.com/results/whatever, right? The /results is an endpoint for the YouTube server. And whenever we send requests, those endpoints are kind of like addresses, because at those specific URLs or specific endpoints, we have separate functionality. So whenever we send a request to a specific URL, that functionality is going to be ran, and we hopefully get the data that we want. So an example would be suppose we're in port 3000 land. Suppose I'm sending a request to localhost 3000, and that request is going to be towards the endpoint API/comment. So I want to post a comment onto my catbook. Well, imagine we're the request, and we're walking down port 3000 land, and we see one house that's addressed as API/videos. We know that that's not the endpoint that we're looking for, so we go on to the next house. Oh. And the next house is going to be get API comments, which is not what we're looking for. We want to post a comment. And then we find the URL that we're looking for. And so we go inside that house. We run whatever functionality we need. We get the data that we want, and then we get out of there, and we're now a response object, and we go back to the client server. And then the rest of the houses are whatever URLs we're using. So after that, we're going to create our first API endpoint, and I'll pass it on to Daniel.
I realized that out is spelled miscorrectly here, or R. OK, well, anyways. Yeah, so our server.js file that we mentioned earlier, we can start off by thinking of it as kind of these two lines. And these two lines is enough to essentially create an API endpoint for our front end to access. The first line is const app.express, and express is some sort of imported package that we have from package.json, and then when we call express, we're going to get this app object that we can then use to create API endpoints. Whenever we call app.get, this creates essentially a GET request, or sorry, a GET endpoint that is able to be queried by any client at that endpoint. Similarly, app.post will create a post endpoint. So app.get takes two arguments. It takes the first argument, which is the endpoint, and secondly, it takes a callback function, which is called whenever that endpoint is pinged, basically. And here we have set up this GET request so that whenever that endpoint is pinged, it will return back to whoever sent that request, wow, I made my first API. Yeah. So this is the HTTP method. So if we set this as post, then we would get a post method. This is the route that Express sets. So essentially the endpoint, whatever, this will be tagged onto whatever base URL we have, for example, localhost 3000. And finally, we have the function handler, which takes in, the function that we feed in should always take in two parameters, the request and the response object. I don't know if, yeah, so this request and response object, request is basically the incoming request that we get, and we're able to do things here like look at what the request body is or the request parameter is or things like that, so we can find out whatever we want to know about what the original request was. And then res is the way that your server sends the response back to the client. So this res.send thing is basically the syntax for the server sending back whatever information it needs to the client. Yeah. And then, yeah, this syntax is basically just the way that Express is set up. But the main thing that you need to know is this res.send. You can put whatever you need inside of it. And it's basically like a return statement. Cool. Any questions here? All right. We're going to talk a little bit about middleware now. So now that we've kind of have like a baseline understanding of like what an endpoint is, middleware is basically what we can do between receiving a request and running the endpoint code. So you can imagine we get the request somewhere over here, and then maybe before we want to like call the endpoint code, we want to do some extra stuff, and we'll like give a few examples on the next slide, basically. Like you can imagine they're like workers in the assembly line, which might like do part of like what we need to do, and then pass it on to the next worker, which will do something else, and then et cetera, until we get to the endpoint, which finally completes our request with what needs to actually be done, essentially. Yeah. Middlewares are called in order of definition, and we'll see what that means in a little bit. Yeah. So a few examples of middleware. Maybe for every request coming in, we want to log the request. And it would be pretty tedious to put in every single endpoint that we ever write before we do that endpoint to console log the request, right? So what we can do is we can just define a middleware in front of all of our endpoints to console log whatever's coming in. And what that will do is no matter what endpoint is being pinged, it'll always console log whatever that request is. So that code will always be run, and you don't have to put it in every single endpoint, right? Yeah, maybe we want to make sure that whenever the user makes a new request, check that they're logged in first. So maybe the user's like feeding in like some sort of credentials or something like that for whenever they make a request. We want to check that those credentials match what is on our server. So we would write a middleware to check that these credentials match what is actually on our server. Yeah, and then finally, if we can write some middleware so that if any request ever results in an error, then we can log that error to the server. And one thing to note is that whenever you console log on your server, it'll print to the terminal that you're running npm run start in. And we'll talk a little bit more about what that means, but basically, it's not going to print to your browser. So that's like the main differentiation here, which is that like you should not like whatever server code that you have that is running console.log, you should not look to your browser, but rather to your terminal. Yeah. Okay. Yeah. So the way that we add middleware is by using this app.use function. So we've talked about app.get, which creates a GET request. And similarly, you can do app.post, which creates a POST request. App.use is another functionality of Express that allows you to register a middleware. So the way that app.use works is it takes an optional path in a middleware object, and we won't talk about the path for now, but basically, if you just feed in one parameter, this parameter will be treated as a callback function, which will be called whenever the request comes in. It takes 3 parameters, rec, res, and next. So the next thing, which is optional, is just the next. It represents like the next middleware function that needs to be called. So if you don't have any, if you only have one middleware passed in, then you don't actually need this next like parameter. But otherwise, the rec and the res are pretty similar to like what rec and res are for like app.get, for example. Like the rec represents the incoming request, and then the res represents how you send that result back to the server. Here, we're not using either. We're not using any of the parameters. We're just going to log the time whenever any request comes in. So maybe like turn and talk to somebody near you for like 30 seconds, a minute, and like try to understand like what exactly this code is doing. Yeah, okay, cool. Do people need more time, or are people good? I don't see anything. Okay, yeah. Cool. Basically, what this code is doing is whenever we have like any endpoint called, no matter what that endpoint is, we're going to basically just log that, log the current time to the console. So if, for example, /API/test is called, what will happen is we'll log time, and then we'll do whatever is defined in /API/test. Yeah. Okay. Now we'll talk about error middlewares for a little bit. So error middlewares are slightly different from middlewares in the sense that they kind of a catch to what happens if whatever endpoint code or whatever middleware code that we run somehow errors in the process of like those processing. Yeah. It takes in 4 arguments: error, rec, res, and next. And the error thing is basically just an object which tells us a lot about what is going on in that error. So just as an example, if you type in error.status, that will just represent the status code of the error that is coming in, and then all the other arguments represent the same thing that we just talked about for normal middlewares. Unlike normal middlewares, which are defined before endpoints, so they're processed before the endpoint actually processes, our error middleware is defined after all of our endpoints, so that if any of the endpoints or the middleware like errors out, then it like kind of it defaults into like what is going on in our error middleware, basically. Yeah. So when we call app.use with error, rec, res, and next, we can put in any error handling code inside. For example, maybe we like print out the error to the console. Yeah. Cool. Finally, we'll talk about catch-all endpoints. And catch-all endpoints are defined. This is like kind of taking a step back from middlewares and going back to endpoints. Catch-all endpoints are defined using app.get and this star symbol. So all endpoints which are not concretely defined will hit the star endpoint. So just an example, what will we get when we get /API/test in the code below? Will we get I love WebLab, or are we going to get a 404 not found? Maybe like open hand for I love WebLab, close hand for not found. What do we think? Okay, I saw a mix. So we're actually going to get the 404 not found because we misspelled /API/test here. So if you're making a request to an endpoint and then you misspell the endpoint, then it's not going to hit the endpoint that you think you're hitting. So here we're going to get back 404 because we like used the wrong endpoint, basically. Yeah, so what happens is basically it'll miss the /API/test endpoint, and then it'll hit the catch-all endpoint, which is defined to kind of catch anything that is not already caught by things that we already defined. Yeah, so we'll get this 404 not found error. Cool. Any questions there? Okay. Yeah, so now I've written the exact same code, but I've switched the ordering of the two so that the app.get star comes first, and then the app.get /API/test is coming afterwards. So how is this code different? Basically what happens here is kind of something weird. Even though /API/test like is defined, when a front end or when a client tries to query the /API/test endpoint, it'll still return 404 not found because in Express, it kind of goes like top down in your file. So what happens is like it'll check each one in order, and then it'll see, oh, this one is like a catch-all endpoint, and so I should be returning 404 not found here. And it doesn't even see like what's happening below, where like it won't even like get to I love WebLab. It'll just like it'll see the catch-all endpoint, which is catching /API/test, and then it'll return the 404. In general, we don't want to do things like this because it's just like not the behavior that we want. So we generally define our catch-all endpoints after all of our like actual defined endpoints, so that those catch-all endpoints should only catch what happens in the case that we missed the endpoints that we actually wanted to define. Yeah, cool. Yeah, so we're gonna check out a little bit of template code in Workshop 3 Starter. Yeah, so first we'll git reset hard, git checkout Workshop 3 Starter. Looks like we're a little behind. So, and then what's going on? Okay, cool. Yeah, so you'll notice our folder is set up similarly to how what is mentioned, in the sense that we have a client folder here, which has all of our source code in it, similar to what basically this is what we worked on in Workshop 2. And then we have a server folder, which currently just has one file in it, server.js. Yeah, so you can like take a look through this, and I'll be doing the rest of this on the slides. So it should match what is in your code, but I think the slides are a little more clear, basically. Yeah. So how do you run the code? So far, we've been using npm run dev to run our front end, which runs our front end code on localhost 5173. But now we will have a backend as well. So in order to run that, we will be using npm start to run our backend, which will run our backend on localhost 3000. Yeah. What's nice about this is that both the front end and the back end will auto refresh whenever you update a file. So you can just keep them like basically running in the background whenever you're like making changes to your files or doing development, so that, and like whenever you save a file, it should be automatically reflected. So you don't have to like rerun these commands ever. You can kind of just keep them running and make changes to your files as necessary. Yeah. Any questions here? Cool. Okay. Yeah, so At the top of our Express code, we have these two libraries, and basically, when we have this const express equals require express thing, you can think of this basically as an import. It's just a different syntax for importing, but generally on the back end we use this require syntax because that's just like that's just like the preferred syntax for like Express and backend in general. But it means the same thing as like a similar import expression, basically. So yeah, these two lines import libraries that we might use in our backend, and then the next line, which is const app.express, creates an app object that allows us to define any middlewares or endpoints that we use. The first thing that we define is this app.useExpress.json, which is a middleware that converts our request bodies to JSON. Request bodies generally come as strings. So it'll just be like a string that probably like has like a list or an array or like some JavaScript object in it, and like our server won't know how to handle like just like a string that's coming in. So you need to be able to parse that string into like a JSON object. So this app.useExpress.json kind of converts whatever's coming in into like a JSON format so that we can actually like process it basically. Finally, we have this app.get /API/test, which is our first API endpoint, as we talked about earlier. This essentially just sets up an API endpoint at this URL to handle, to return this message whenever it's pinged. Yeah. Cool. The next thing that we have in our code is this catch-all error handler, which uses like the catch-all star syntax. So you can turn and talk for a bit and like discuss with somebody next to you, like what is this code doing? Yeah. I'll give you guys like a minute or something. Yeah. Okay. Cool. Do people need a little bit more time, or I'll give a few more moments. Yeah. Okay. I think I heard some like a few like correct things like being said around the room. Yeah, if we get like some, basically whenever we get a request that is not something that we've already defined, then this app.all is going to catch it and print out both the method and the URL. And app.all is not something that we've talked about yet already, but if you guessed correctly, then good for you. Basically what it does is it processes all types of endpoints, or sorry, all types of methods. So get, post, and any other methods that our request might have. So it kind of defines it for both get and post, and maybe like delete or whatever other things, right? Yeah. And then once we catch the route, we'll console log the route to the terminal so we see it on the server side, and then the res.status 404 sets the status to 404, and then we send it back to the client. So the idea here is the first line helps us see it on the server side, and then the second line helps us see it on the client side. Yeah, so when we send it back to the client, then the client will also see that there's an error. Cool. I think I will probably like skim past this part. Basically, this last part is server error handling middleware, which is error handling middleware, which basically, whenever we get an error from the server, we will log the error, which will be seen in terminal, and then we will send that error back to the browser. And if we have a status code that is already passed to us, then we will keep that status code. And otherwise, the default status code will be 500, which is basically something we went wrong on the server side. And we apologize, but we have to log that the server errored, and we also have to tell the client the server errored, basically. Yeah. Cool. OK, I think that's it for this lecture. Yeah, so the next thing that's coming up is workshop 3. For now, while we transition to that, take a few moments and fill out the feedback form, web.is/feedback. And yeah.